All right, so in this video, we're going to graph the transformations of exponential functions, okay? So in a previous video, we had graphed f of x equals 2 to the x power, okay? Remember, we talked about all exponential functions having a horizontal asymptote. And the horizontal asymptote occurs at y equals whatever the constant is here, okay? Well, there is no constant here, so the horizontal asymptote in this basic function 2 to the x was at y equals 0, or the x-axis. Now, in the function here that we're going to be graphing, g of x equals 1 plus 2 to the x, we've got a constant of 1, okay? So that means we've got a horizontal asymptote that is moved up 1 to y equals 1, okay? So we're going to have a horizontal asymptote here, okay? Now, unlike the rational functions that we recently graphed, the horizontal asymptote for exponential functions only is useful for one direction. It's either going to be going towards negative infinity or going towards positive infinity. And it depends on what kind of function you have. Is it exponential growth or is it exponential decay? Okay. Now, in this case, what we're looking at, when we think about the transformations that we learned previously, when we were graphing quadratics or cubics or absolute value functions or other functions like that, this resulted in what we call a vertical shift. Okay. And you can tell from the horizontal asymptote that vertical shift is going to be up 1, okay? Now, you can evaluate. You can plug in these values for x in here and for the variable and do all the math. Or you can realize we've got a vertical shift, and all of these y values, all of these f of x values are going to grow by 1, okay? So in my new function here, negative 2 is going to correspond with 1.25, or it's 1 greater than 0.25. When I plug in negative 1, I'm going to grow this by 1, so 1.5. 1 becomes 2, 2 becomes 3, 4 becomes 5, and 8 becomes 9, okay? So what we have here is a vertical shift up 1 unit, okay? So let's use Desmos.com. It's a really good online graphing calculator. So we've got the graph of 2 to the x, okay? I'm going to copy and paste that down here. So if we do 2 to the x and then we do plus 1, okay, you can see that vertical shift. Every point on the blue graph has been moved up 1 point on the red graph. Okay, so this point up 1. This point up 1. Over here, we went up 1, okay? Now, let's just keep talking about vertical shifts. What if I put instead here a minus 3, okay? So you can see from our original y equals 2 to the x, the vertical transition or the vertical transformation here is down 3. So every point on the blue graph would be moved down 3 units to create the red graph, okay? Let's say I just want to take away 1 instead. So it would be a vertical shift down 1 and so on, okay? So that's the vertical shifts. If we add or subtract a constant out here with the exponential piece, we're going to move the graph either up or down by that amount. Okay, so there were a couple of other types of transformations we could have. Now, we just talked about the vertical shift, and a little bit later we'll talk about the horizontal shift, but we also had different reflections that we could have, okay? Reflections about the x-axis or reflections about the y-axis, okay? Now, if we think about our basic function f of x equals 2 to the x, the only difference here is we're changing that 2 to the x to its opposite, or negative 2 to the x, okay? So what happens is, as these x-coordinates stay the same, from negative 2 to 3 here and here, my y-coordinates are going to be the opposite. So when I plug in negative 2, instead of 0.25, it's going to be negative 0.25, okay? Sorry, we skipped over the horizontal asymptote here. There is no constant, so we've got a horizontal asymptote at the x-axis, y equals 0, okay? So back to it. Negative 2 corresponds with 0.25 in the original function. It would be the opposite here because the difference between the two functions is just that we've got a negative f of x here, okay? So instead of negative 1 corresponding to 0.5, it's going to be the opposite of that, or negative 0.5. 0 doesn't correspond with 1 anymore. It corresponds with negative 1, and then negative 2, negative 4, and negative 8. Okay, so let's look at that graph real quick, and you'll see that what's happening here is we're reflecting this about the x-axis. Because y becomes negative y, or because f of x becomes negative f of x, we've got a reflection about this x-axis, okay? So let's look at that. So let's get rid of this. And again, I'm just going to put a negative here. So that red graph should be a reflection. Okay? And you can see that every point along this blue graph here can be reflected. Let's just choose this point right here. We've got our reflection down here using the x-axis as our line of symmetry. Okay? Again, to the left, we're approaching that horizontal asymptote, y equals 0. Okay? So if we change f of x to a negative f of x, it's a reflection about the x-axis. Now, if we change x to negative x, it should be a reflection using the y-axis. Okay? So say we've got this point here, it's going to be reflected about the y-axis over here. Okay? So there's those two reflections, changing x to negative x, like in that case, or changing f of x to negative f of x. So that creates the two different reflections. So let's go over the horizontal shift now. All right, so the horizontal shift, remember thinking back to our quadratics, our cubics, our absolute value, all the transformations we worked on. Okay, if we were adding or subtracting something from the x, it created a horizontal shift. Okay, and back then I referred to it as kind of counterintuitive. When you see this -1, you think, well, it's going to be a shift to the left 1 unit. But it actually doesn't happen that way. It actually shifts everything to the right 1 unit, okay? Now, initially, just using the same x values for the basic function and for the one we're transforming, okay? If I plug -2 in here, I get 2 to the -3rd power, which is 1 over 2 to the 3rd, or 1/8, okay? And again, I forgot the horizontal asymptote. No constant out here, so the horizontal asymptote at y equals 0. So again, I should get 1/8 there, okay? Now, everything else, as my x value shifts from -2 right 1 to -1, then the y coordinate should stay the same, okay? So -1 should correspond with that 0.25, okay? So it's going to be, we're shifting that to the right 1, okay? Notice again, if you want, you can just plug this in. -1 minus 1 is -2, which is 1 over 2 squared, or 1/4, okay? But all these other points should be shifted right 1 unit, from -2 to -1, from -1 to 0, from 0 to 1, okay, from 1 to 2, and from 2 to 3, okay? All right, so this, you know, here subtracting 1 from that x within the exponent there creates what we call a horizontal shift, right 1 unit, okay? So let's take a look at that on the graph here. So we need to, let's do this. We'll do x minus, I think I got to put it in parentheses here. Let's take away 1, okay? So you can see again, our original graph is in blue here. So everything's being shifted to the right 1 unit. This point shifted to the right 1 unit. Now, if I change this from a 1 to like a 3, you'll see that horizontal shift to the right 3 units. 1, 2, 3, okay? Let's pick another point up here. 1, 2, 3 units to the right. Now let's change that to a plus sign. Let's go +1, and you should see a horizontal shift to the left. Okay. Let's change that to a 4, for example, and you would see this original function is shifted 4 units. 1, 2, 3, 4 units to the left. Okay. So with the horizontal shifts, it's actually counterintuitive. Whatever is going on in here, in this case +4, doesn't mean we're going to the right 4 units. It actually means we're shifting to the left 4 units.